Hello everyone, welcome back. In this video we're going to be starting a new unit and it's over polygons. So we're going to begin with talking about angles and polygons. Okay, here are the things that we're going to be talking about in this specific video. It's mostly just going to be finding missing angle measures in regular polygons, both on the interior and the exterior of the shape. So by the end of the video, you will be able to find the missing measure of regular polygons. Okay. A few things before we start, we need to talk about a few new definitions. Okay, this first definition here is just a diagonal. And a diagonal just connects two non-consecutive vertices together. These are just different kinds of polygons that we're going to be talking about here. We have convex polygon, where all the diagonals are occurring inside the figure. So we could draw, in this case, we could draw from here to this one and this one because they're non-consecutive. And I would just do that for each one of the vertices. And on the inside, it creates this star. On the flip side, the concave ones, this is where one or more diagonals occur outside the figure. So if you were to connect some of these together, it'd be kind of funky, but we're not going to spend too much time with concave polygons. All right, so the first part of this unit is going to be finding sums of interior angles. So we all know that a triangle has 180 degrees. So I've got this little sheet here that helps us to determine how we come about this 180 degrees and the sum for each one of the other shapes. Okay, so we start with the triangle. The triangle has three sides. And it has no diagonals because we can't connect any of the vertices together because all of the vertices are consecutive, which means that they're just right next to each other. Okay, so with the triangle, we have no diagonals. We end up with one triangle. Triangle is 180 degrees. With a quadrilateral, if we were to connect the diagonals here, okay, the way that it would look, okay, we just use one vertex. So if I started down here at this vertex, the only diagonal that I could create is going straight across to the other one. And notice that we have two triangles. We have a triangle over here on this left, and then we also have one on the right-hand side as well. So we have one over here on the left and then one on the right, two triangles. Okay, so to figure out how many degrees are in this quadrilateral, okay, you can think of a quadrilateral as a square or a rectangle. Quadrilateral just means that we have four sides. Quad means four, and then lateral is a side. We know that quadrilaterals have 360 degrees for the sum of the interior angles. Okay, but if we take the 180 and we multiply it by 2, the number of triangles, that also gives us 360 degrees. Okay, we're going to do the same thing with the pentagon this time. So the total number of diagonals that I can draw from this top vertex here is going to be 1, and I come down here, and that makes 2. So I have two diagonals. Looking at the picture, I end up with 1, 2, 3 triangles. So if I take 180 and multiply it by 3, that's going to give me 540 degrees for the sum of all of the angles inside this shape. Okay, the rest of the chart is basically just going through the exact same thing. So once this is all filled out, you'll notice a reoccurring theme here. Depending on how many diagonals you can create will determine the number of triangles that are inside whatever shape you're looking at. So if you're asked to find the sum of the interior angle measures, all you're doing is you're taking 180 degrees because that is the number of degrees in a triangle, and you just multiply by how many triangles you have to get the sum of the interior angle measures for each one of these. You do the same thing down here for the decagon, the dodecagon, so on and so forth. Okay, so this brings us to the kind of polygons that you can do this with. You can only do it with regular polygons. In other words, polygons that have the same angle measure and the same side for all of the angles and all of the sides. Okay, so you can't have, like, for instance, a quadrilateral that has a 45-degree angle, another 45-degree angle, and then the other two splitting the difference or being split between 360 minus 90. So when we're talking about our polygons here, all of the shapes that we're dealing with have the exact same angle measure and the exact same side length for every side and every angle. Okay, so here are some of our examples of regular polygons and kind of what they look like. Okay, our special formula to find the interior angles of regular polygons. Okay, each interior angle is going to be found using this formula right here. So we're taking 180 degrees, that's the triangle. We take the total number of sides, that's what n is. N is the total number of sides. We subtract 2 from it, and then we multiply that with the 180, and then everything that's on the top gets divided by the total number of sides on the bottom. Exterior angles are super easy to remember because the sum for any polygon is always going to be equal to 360 degrees. So the sum of the exterior angles for any polygon is always going to be 360 degrees. To find exterior angles of regular polygons, we have to take the total sum, which is 360, and simply just divide it by the number of sides. Okay, this formula right here only applies for regular polygons. Okay, so let's go ahead and start taking a look at some of these examples here. Oops. Okay. So the first thing that we need to do is determine what we're looking for. So in this case, we're trying to find the sum of the interior angles of a 22gon for part B and for part A convex decagon. Okay, so the first thing that we're going to do is write down the formula. All right, so here we have our formula. The sum of the interior angles is equal to 180 degrees times the number of sides minus 2. Okay, this applies for any polygon that is regular. And this works for the sum of the interior angles only. Sometimes what we'll see is this big S. Big S is the sum of the interior angles, if you ever see that. All right, so just like we always do, okay, the next step would be to take what we know and just plug it into our formula here. So for part A, the sum of the interior angles is going to be equal to 180 degrees times n minus 2. In this case, okay, We have a decagon, that's 10. So n is going to be 10. So all we do is we replace n with the number 10. We subtract 2 from it, and then multiply by 180 degrees to find the sum of the interior angles. So for this one, big S is equal to 1,440 degrees. Okay, we can do the same thing with part B, the 22gon. I want you to go ahead and do this one on your own, and then we'll come back with the solution. All right, so here's our work. Pretty much the exact same thing that we did over here with part A. Part B, the only difference is we substituted in with 22. 22 minus 2 is 20. So when we multiply the 20 to the 180, we get our total of 3,600 degrees for the sum of the interior angles of a 22gon. Okay, this example here gives us the sum of the measure of the interior angles, and it wants us to classify this polygon by its sides. Okay, so generally speaking, anytime that you see this right here, the sum of the measures of the interior angles, we're going to use this formula. Okay, the big S. Okay, so we're using this formula here for this problem, and we just plug in exactly what we know. Nothing changes with our process. We're still plugging in what we know. So we know that the sum, the big S, is equal to 1,260 degrees. So I put that over here on the left-hand side, and I set that equal to 180 times n minus 2. Okay, my goal is to find what kind of polygon this is and classify it by the number of sides. Remember what n is. N is the number of sides. So our goal is to get n by itself. Okay. The first step to doing this, we have to get the 180 and the -2 over here somehow. Okay, use PEMDAS. Please excuse my dear Aunt Sally. This is an acronym for parentheses first, exponent second, multiplication, division, addition, subtraction. So you do each one of these things in this order. Okay, I can't do anything inside the parentheses. There's no exponents in this problem. So then I go to the multiplication. So that's the 180 times all of this. To get rid of the 180, I have to divide 180 on both sides because that is the opposite operation of multiplication. This cancels out. And then over here, 1,260 divided by 180 is 7. Okay, so now we have 7 equals, the 180 is gone. I'm left with n minus 2. Remember, we still got to get n by itself. I do the opposite operation here with the -2. So I add 2 to both sides and end up with n being equal to 9. So this shape has 9 sides, which is a nonagon. Okay, so again, the key here is when you see the sum of the measure of the interior angles, you're going to be using this formula. All right, example number 3, trick questions. The answer should be the same for both. I'm going to let you go back to your notes and tell me what the answer is. Okay, so we're back. The sum of the exterior angles. Remember, this was one of our slides where we talked about our definitions. The sum of the exterior angles is 360 degrees. So it doesn't matter what kind of shape you have, it's always going to be 360 degrees. for both? Okay, trick question. The sum of the exterior angles for both of these is 360 degrees. All right, this question here is a little bit different because now we want to find one exterior angle of each of these shapes. Okay, so notice they're both regular polygons. So since I have a regular polygon, if I'm looking for one exterior angle, what I need to do is I need to find, or I need to use this formula here. The exterior angle is equal to 360 degrees because that's the total sum, and I'm dividing it evenly by the total number of sides for the polygon. Okay, so in this first one here, a nonagon is 9 and a pentagon is 5. So my exterior angle for part A is 360 divided by 9. So each exterior angle is going to have a measure of 40 degrees. Okay, with the regular pentagon, we use the same formula. And your answer, I'll let you tell me, is going to be 72 degrees. 360 divided by 5 gives us 72. Okay, sometimes you'll see problems like this. So when you're trying to find the value of x, you're just paying attention to where all of these angles are. Okay, if this was on the inside, the first thing that you would have to do is find the big S, the sum of the interior angles. And then after that, you would set it equal to all of these things that are added together. Okay, but in this case, this picture shows us that all of the angles are on the outside. So our sum is 360 degrees. And that's going to be equal to me adding all of these together. I'm going to add up all of the outside angles together, and the total sum is going to be equal to 360 degrees. So the way that that looks, I'm just going to label these as 1, 2, 3, and 4. I'm going to add the x plus the 89 plus the 2x plus the 85. Okay, and then from here, it's just solving an equation. I combine all the x's together. 1x plus 2x is 3. I combine my numbers together. 89 plus 85 is 174. Then I solve for x. Take away 174 from both sides. This cancels out. This gives me 2, 16, it's 15, so we had to subtract that. So that's 8. 186 is equal to 3x. Divide by 3 on both sides. X is 62. That's what they wanted. They wanted us to find x. X is 62 degrees for this one. Okay, last example here. This one, you have to kind of work backwards a little bit and really pay attention to what's said here. So what they tell us is that we're given one exterior angle of a regular polygon. They want us to find the number of sides that it has. So the exterior angle that's given is 120 degrees. Okay, so I start with what I know. I know that I'm given an exterior angle, which is 120 degrees, and that's equal to 360 divided by n, right? That's just coming from this formula here. The one that we used, I believe it was 2 examples ago. Okay, so I just took this formula and plugged in what I know, which is 120. Okay, now we're just solving for n. Okay, so to do that, this is like what we talked about in the last unit with the trig functions. These are just going to replace each other because I'm multiplying by n on both sides. And then I have to divide by 120 on both sides to get rid of it on the left. Okay, so as you can see here, these just replace each other. N is equal to 3. What shape has 3 sides? A triangle. So that's it for this video. One of the keys here, again, comes back to this one. So if you're given a question like kind of like this, where it says find x, and all of the angles are on the inside, what you're going to do is you're going to calculate the big S. You're going to calculate big S, the sum of the interior angles, by knowing how many sides there are. And then once you do that, you do exactly what we did in example 6. You take, what we did here in example 5, you take the sum, and then whatever the angle measures are here, you're going to add them all together and set it equal to the big S. All right, so that takes care of interior and exterior angles of polygons. In the next video, we're going to be talking about parallelograms.